Okay, I have to find the remainder obtained by dividing this polynomial p of x by x plus 1. So I'll call this as g of x is equal to x plus 1. Fine. So I have to find the remainder obtained by dividing p of x by g of x. So p of x is already arranged in the descending order of powers, and g of x is also arranged in the descending order of powers. So I'll directly do it by long division method. So it is x cube plus 0 into x square plus 0 into x plus 1. Correct? I am writing x square and x terms because while doing the division I will be getting these terms. So I just wrote them for the sake of understanding. So I'll write my g of x here, which is x plus 1. So here whatever I'll get, that is the quotient, and at the end whatever is left over, that is the remainder. So what is the first term of the quotient? That is the term having the highest degree of x, that if I divide by the term having highest degree of x in the divisor, that will be my quotient, because I will try to eliminate my highest degree terms so that I have to deal with smaller and smaller degree of terms. Okay, so that will be x cube by x, which is x square. So if I put it as x square here, then x into x square is x cube plus 1 into x square is x square. So this, if I subtract from this, x cube minus x cube is 0. So these will get cancelled, and 0 into x square minus x square will be minus x square. Correct? Minus x square plus 0 into x. So now what will be the second term in the quotient? Here x square has a power of x which is greater than 1. So I can divide it once more. So the next term will be minus x square divided by x, which is minus x. So it is minus x. So this will get it as minus x square minus x. So this, if I want to subtract, then upon subtraction I will get, these two will get cancelled, and 0 into x minus minus x, that is x, and the next term in the dividend is 1, so x plus 1. So here the power of x is 1, which is same as this power of x, so I can still divide it once more time. So x by x is same as 1, that is this term divided by this term is 1. So the next term in the quotient will be 1. Okay, so if I multiply x plus 1 into 1, that is x plus 1. So if I subtract x plus 1 from x plus 1, I will get 0. Okay, so this is my quotient. I'll call it as q of x, and this is my remainder. Correct? Why is this the remainder? Because here the degree of this polynomial is less than the degree of this polynomial. Therefore, this is my remainder. So I'll call it as r of x. I can see that remainder r of x is equal to 0. Therefore, the remainder obtained upon dividing p of x by x plus 1 is 0. There is an easier method to calculate the remainder. That if I have x plus 1 here, this is a polynomial of degree 1. This is a monomial. So remainder of p of x when divided by a monomial is same as, is equal to the value of p of a, where a is the 0 of the monomial. Okay, this is valid only for the monomials, that is having degree only 1. So this is a easy method to calculate remainder when divided by a monomial. This is generally called as the remainder theorem. Okay, so if I apply the remainder theorem, then what is my p of x? P of x equal to x cube plus 1, and g of x, it is a monomial, right? because x plus 1, the highest degree of x is 1, so it is a monomial. So what is the 0 of g of x? That means if I put x plus 1 is equal to 0, then x is equal to minus 1. So this means that minus 1 is 0 of g of x. So what will be the remainder of p of x when divided by g of x? That will be simply p of minus 1, correct? What is p of minus 1? That is minus 1 cube plus 1, which is same as minus 1 plus 1, which is 0. As you can see, you can get 0 by both the ways. Therefore, this is a faster method if you are having to divide a polynomial by a monomial.